Gravel roads are a vital part for the transportation infrastructure, especially in rural and remote areas. However, due to their unpaved nature, they are prone to various type of surface deformation and defects that can affect their functionality and safety. Below, we will explore and main issues that affect gravel roads. Surface deformation refers to the physical changes in the road's surface caused by traffic loads, weather conditions, and inadequate maintenance. This deformation can significant impact the road's usability and safety. The most common types of surface deformation in gravel roads include cause of surface deformation, traffic loads, weather conditions, poor drainage, inadequate gravel layer. Potholes are one of the most common and noticeable surface deformation in gravel roads. They are depression or holes in the road surface that can vary in size, in depth, um, causes of potholes with their infiltration, traffic wear, lack of maintenance. Washboarding, also known as corrugation, is a series of transverse ridges and depressions that front across the road surface, resembling a washboard. Cause of washboarding traffic acts known poor road bed stability, improper grading. Rats are longitudinal depressions or grooves in the road surface, typically following the wheel paths of vehicles. Cause of rats, traffic load, poor drainage, inadequate crown.
Ducts. Traffic on the gravel roads can generate ducts. Good quality gravel used in the construction of gravel roads has a combination of large aggregate, sand, and fine material or binder. Los aggregate on unstable surface gravel conditions can develop from lots of fines through heavy duct action or from erosion due to an improper gradation mix of the original aggregates. Rating road surface condition. A simplified rating system has been developed to help manage gravel roads. It uses a scale of 1 to 5, 5 is excellent condition and 1 is a failed. Rating 5. Excellent. Little or none maintains records. Rating 4. Good. Routine maintenance may be required. Rating 3. Fair. Regrading and draining improvements. Spot gravel application need. Rating 2. Poor. More gravel and major drain improvements required. Rating 1. Failed. Reconstruction required.
Unpaved route. The unpaved route network of a facility comprises all unpaved areas that provide access route for ground traffic, including roads, parking areas, storage areas, then road and ridge road. A unit code is assigned to each of these elements for to facilitate data storage and retrieval. This code consists of 5 characters, which can be numbers of letters, assigned to the different branches in logical order. The first letter of the code identifies the type of branch, and the number indicate the building closest to the parking areas. Branch, an identifiable part of the unpaved route network that constitutes a single unit with an specific function. For example, individual road parking areas, then road and ridge road. Section. And section is a division of a branch that maintains certain consistent characteristics throughout its area of length. These characteristics include structural composition, construction history, traffic, surface condition. Assembly unit. Assembly unit is identifiable area within an open fruit section and represent the smallest unit in the open fruit network. Each open section is divided into separate units to facilitate inspection of this condition. For open route, a sampling unit is defined as an area of approximately 2,500 square feet. Guidelines for identifying open route. Dividing the open route network into branches. The first step is to identify the branches within the Open Run network. The easiest way to do this is to use the facility existing naming system. For example, in the figure 2, the one boot hit road would be identified as a branch areas such as parking lots and storage areas that do not have assigned names can be give descriptive names that associate that with their location. In addition to descriptive names, branches are assigned a unit code to facilitate data storage and retrieval. This code consists of 5 logic assigned alphanumeric characters.
Dividing ramps into sections. Ramps are large units within the on-pavement road network. They are rarely exhibited in uniform characteristics along their entire length. Therefore, for maintenance management purpose, each ramp should be subdivided into sections with consistent characteristics. A section should have a uniform structural composition, similar traffic, and their same construction history. After each section is initially stabilized, surface condition, drainage, and shoulders can be used to subdivide it if considerable variation in condition is observed. Dividing ramps on the unpaved road network. A structure. This is one of the most important criteria for dividing a branch into sections. Structural information is not always available, but it can be obtained by reviewing construction records, inspecting repairs, or drilling holes and cores on the surface. B. Traffic. The volume and intensity of traffic loads must be contained within each individual section. C. Construction history. All parts of a section must have been built at the same time. Records constructed at different periods must be divided into separate sections. Unpaved road category. If a roadway changes category along its length, for example from second to third class, a division sections must be made. E. Drainage facilities and shoulders. It is recommended that the shoulder types and drainage facilities be consistent through a section. If test areas, an area where test materials have been placed must be identified and separate section. Branches of the pavement road network can be divided into sections using the criteria above. Sections are assigned numbers starting with 1 at the north or west end of the branch and increasing south or east. Second, to identify a section on the facility map, and a road should be placed at the beginning and end points of each section as shown in figure 2 to 3. 3. The above criteria can also be applied to other types of ramps such as parking lots, storage areas, and town paths. These ramps are typically considered a single selection but can be subdivided if necessary. For an example of dividing a parking area into sections is shown in figure 244. Section division is based on traffic and usage patterns. Dividing a section in sampling units. Sampling units are the smallest part of a pavement road network and are used to inspect the surface conditions. Sampling units are generally 100 feet long. If the road is less than 15 feet wide, the length should be increased. If the road is more than 13 feet wide, the length should be reduced.
For this third chapter, we cover the classification of unpaved road conditions. The general outline basically includes an explanation of classification methods, the calculation of the unpaved road condition index (URCI), and recommendations such as a maintenance records and the number of annual inspections. It is emphasized that the data obtained will allow us to establish requirements and priorities for maintenance and restoration if necessary. On the other hand, it's the key to mention that seven types of problems are identified for a road condition classification, such as an inadequate cross section of the roadway, inadequate drainage, corrugation on the road surface, dust or particulate matter, presence of bottles, presence of rats, and finally loose aggregate on the surface. For the classification of an unpaved road, several factors must be taken into account. These include structural integrity, the road's structural capacity, roughness, and deterioration rate. It is important to keep in mind that make these determinations. The road must be divided into branch and previously mentioned. The paved road condition index is scaled from 0 to 100. The author states that it's similar to the pavement condition index for paved roads. A high index indicates good conditions, while a low index indicates severe deteriorations.
The UCRI is determined based on field deterioration measurements.
Unsurfaced road inspection. Before an unsurfaced road network is inspected, it must be divided into branches, sections, and sample units as described in the chapter 2. Once these divisions is complete, survey data can be obtained and the URC of each section determined. There are two inspection methods: a quick inspection from a moving vehicle and detailed measurements of the trace and the sample units. Windshield inspection. The inspection is carried out or by driving along the road at 40 km per hour, adjusting the speed according the conditions. The speed may be higher or lower depending on the road conditions, local regulations, or speed limits. Surface or drainage problems should be observed, and areas with frequent maintenance should be recorded. These inspections must be conducted 4 times a year, was each season, spring, summer, fall, and winter, to estimate maintenance needs and the priorities. Detailed measurements to calculate URC rings. Detailed measurements as the sample units must be conducted at the least once a year. These measurements should always be performed at the same time of year when the roads are in their best and most uniform condition. To the evaluator must to identify certain steps of deterioration and no one distresses. There are 7 types of deteriorate in unpaved roads: improper cross section, inadequate roadside drainage, corrugation, dust, pallets, roads, and low aggregate. Inspection data record. For inspection data record, the following form must be used to document the inspection data of each sample unit. For example, the previous example until has she following this trace: 100 feet of medium severity improper cross section, 200 feet of high severity inadequate roadside drainage, low severity dust, 419 square feet of medium and severity roads, and 910 square feet of high and severity roads. Remarks: for the inspection of approved roads, each sample unit must be presentially identified, use a permanent marker, and sketch to facilitate the future inspections. It is essential to follow the district definition for Appendix B to obtain an accurate URC. Additionally, any unusual aspect should be recorded, such as the simultaneous presence of different districts steering barrier. If multiple destroys occur together, they should be measured separately. In case of uncertainty, a reasonable estimate is allowed, as the system is flexible enough to calculate an accurate rating.
Calculating the URC from inspection results. General. URCI calculator is based on measure deterioration and the determining using deduct values. Deduct value dV is a number between 0 and 100, when 0 is determination as no impact on the road's condition, but 100 the road is completely deteriorated. Now there are different steps for calculating the URCA from inspection results. The first is calculate the density for each distress type except dust. Density is measured based of the affected area within 168.4 square meters sample unit. Density is amount of distress over area of sample unit for 100%. Now, in two cases, part A and part B. Part A for 100 linear feet of improper cross section, distress type 81, the density is 5.6. Part B for 30.5 linear meters of improper cross-section, distress type 81, the density is 18.2. In the case C, for 900 square feet of corrugation distress type 83, the density is 50. And D, for 83.7 square meters of corrugation distress type 83, the density is the same, 50. In case E, no density calculation is necessary for this distress type 84. F, 160 linear feet of loss aggregate, district type 87, the density is 8.8. And D, for 48.8 linear meter of loss aggregate, district type 87, the density is 29.2. The step number 2, using the deduct value curves, find the deduct values for each distress type and severely level. The deduct value curves are in Appendix C. So, for improper cross-section, allow severity English unit, the density of 5 on seats on the horizontal axis, go vertically up the Y to the low severity curve. Then go left horizontally to the y-axis intersection, which gave a value of 13 English units. Similarly, for the metric system, metric units, the density of 18.2 on the horizontal axis, which gave a value of 13. For part B, for corrugation and medium severely, the tooth value is 99. So enter for y-axis until shock with the line M for find the value density. In part C, for dust at medium severity, the tooth value is 4. You can see in the image the value corresponds medium severity is 4 points. And part D, for loose aggregate at medium severity, the deduct value is 18. Step number 3. Find the total deduct value TDV and the Q value. Calculate the TDV by adding up all the deduct values. The Q value is the number of individual deduct values greater than 5. A TDV is a sum of all values obtained, which is the same in English and metric units. B. The Q value is 3 because 3 deduct values are greater than 5. Step number 4. Find the unsafe rod condition in the URCI from the URCI curve. Now, higher URCIs may result from manual computations. From figure 3, script 5, the TDB is 64 and Q is 3. So the URC curve shows that the URC is 69. From figure 3 script 1, the writing is good. B. This is the writing for the sample unit. The writing for the section is the average of the writing from all the sample units, the section. For example, URCs of 63, 59, and 67 in the section would give an average URCI of 63 for the wall section.